Welcome everyone again to the DS Incubator. This is the series about cloud computing. And today we're going to be talking about how to use cloud computing to host Shiny apps. I'm also going to show how to create a Shiny app, although it's not like the point today. It's mostly how you can use a service like DigitalOcean, for example, so that you can put your apps there with no limit in terms of how many you host. All right, so that's use case number 4. We covered 3 use cases last time. And after this, there are going to be at least one more use case in the next meetup. So the folder that hosts all use cases is number 2, including the ones from previous sessions. So let's type here Shiny to find that quickly. So this is the little bit of that document that relates to what we're going to be talking today. So the first thing you need to do to host a Shiny app is, of course, to have a Shiny app, and you can create it however you like. You can create it maybe locally in your computer and then somehow move it to the cloud. I'm going to talk about that maybe starting the next meetup, on how to move data to the cloud and from the cloud and things like that. But today I'm going to be working directly on the cloud. So I'm going to create a Shiny app directly on the cloud, but still I'm not going to be using the droplet itself. I'm going to be using a little container inside that droplet. So I'm going to be using Docker again. So if you are a little lost with Docker, don't worry, everyone is in the beginning. There is a whole series about Docker that ran a few sessions ago. You can find that in the DS Incubator. And also I'm going to be talking kind of breaking down the calls to Docker myself in this meetup, explaining what each thing does, and then you can read more on the resources that I'm going to give at the end. And also now a good resource to get started with Docker, especially for those who use Docker to run different services in R, is this website here, the Rocker project, which I mentioned many times already. So what I'm going to be doing first is going to be, I need to first make sure that I have a droplet, which is a computer that is going to serve another service to my computer, to me here. So let's do that first. So let's go to DigitalOcean, which is one of the many providers of cloud computing services that you can pretty much hire. So I have an account already, so I'm going to log in. If you don't have one, you can sign up for free, and also you get $100 credit that you can use over 2 months to try it out, which is what I'm doing now. I still have 25 days to go, and I haven't used up all the money yet, so it's pretty, it can take you pretty far, those $100. So inside my dashboard for DigitalOcean, I have this demo project, which is dedicated to the meetup here. And in there, I have a droplet that we created together in this series. I think it was the first time we started with the series. It's already on. We talked about this. Alex, brought that up, and it's good to know that you can turn it off and on. I think you still get charged when it's off. So if you are concerned about costs, you may want to read very carefully the documentation. But also there are ways to cap the your bill to a number or get notifications. So there's a bunch of clever ways to control the way you spend your money. So this droplet in particular is not a big one. It's probably as small as it gets, like 1 GB of memory, 25 GB of disk. It's running Docker on an Ubuntu computer, Ubuntu 20.04. So those are the characteristics. And the most important information we need to work with this droplet is this thing here, this address called IPv4, because we're going to need that address to connect to that droplet. I'm going to do that just now. I'm going to open the terminal in my computer. This is not the cloud. But I'm going to connect to the cloud using SSH, which is a program that allows me to use a special key that I have saved and created and saved in my computer called SSH. So with that command SSH, I can say which user, in this case root, the most privileged user, is going to be working on the container, on the droplet. And now I need to say where to find that droplet. So and I'm going to paste that address that I copied from the dashboard of DigitalOcean. So that will connect me to the droplet from my own computer. There's a bunch of information there. Let's clear this up with Control L. And yes, I'm going to be calling Docker in a moment. So a good thing to do now would be to do a Docker PS to see if I have anything running. With -A, I'm sure that I'm going to see every possible container, including the ones that are stopped. But I get nothing as output, so there is no container running. That's a good place to start. I'm going to go back to the notes, and now I'm going to copy this in a moment and paste it. So this is the call to Docker that will create this little computer that is going to be running RStudio inside it. So with it, I'm going to create later a Shiny app and then show you how you can actually publish it and host it with another container that is going to be running Docker's RStudio server. So the container I'm going to be running right now, again, comes from the Rocker project. It is a container that runs RStudio server, it's called. And let's break this down a little more. So, of course, Docker run will run a container. --remove will remove that container once it is stopped, so I don't have to do any further cleanup. -D is gonna leave the terminal available to interactive work. So after this call, the container will be running on the background, and the terminal that I used to call Docker is gonna become available immediately. The -P8787 is just a way to tell where two computers can meet. So the computer on the left is described here, is the droplet itself, and the computer on the right is the container. These are simply addresses in the internal network of those computers, and that's the meeting point pretty much. The -V flag, we covered it in the series about Docker, about working with Docker, allows you basically to pass folders, files, and things like that between the computer that hosts the container and the container itself. As you probably know by now, on the left-hand side you have the droplet. So there is a directory inside the droplet, a folder called mount, M-N-T. It is right after the root of the system, and the container has the same thing. So anything that I create inside the container and I put there in that folder mount is going to appear automatically on the droplet itself. So from there I can move it around. I can move it to other locations of the Docker, of the droplet, or I can, I don't know, like maybe copy it to my own computer outside the cloud to do whatever. Then for convenience, I'm gonna name this container RStudio because the purpose for me is going to be running RStudio. I'm obliged to use like a password. If I don't give one, I think I get an automatically generated one, but instead I'm gonna explicitly call, pass an environment variable called password with the numbers 1, 2, 3, which is gonna be my password. And I'm also going to use this environment variable called root. I'm gonna set it to true so that inside the container I have privileges to do things like, for example, save files inside this privileged folder. So some actions are at the system level and need only administrators can do it. So a normal user would not be able to save stuff in here, but the privileged user root will. Okay, so that's a lot, I know. In that brief description, I cover things that we cover in an entire series of meetups. I covered things that we covered in the terminal series and also in the Docker series. So if you need to review them, you may want to watch those videos. All right, so now let's do that. So let's copy this and paste that to so in the droplet. So I'm in the droplet running now, and this is the unique identification of the container. I can do now a Docker PS, and you can see that there is a container there. Let me do this a little smaller. This RStudio container. So the next thing I need to do is to go find that container in my web browser. So again, I'm gonna need that address. I'm gonna paste that address in a fresh tab of my web browser, and then say 8787, which is the address that we told the droplet where to find the container. Here is just the normal login. RStudio is the username, and the password 123 is the one that I chose. I sign in here, and I'm gonna be landing in an RStudio project. So far, nothing really different. Only now I'm gonna start talking about the Shiny idea. So I'm gonna create a project in our studio. Conveniently, you can create a new project and you can make it directly a Shiny application. So I'm gonna just call it app and hit create. So that will, close this session. I'll open another one with this working directory set inside that new app directory that I created. So here it is. And also conveniently, there is a file already, which is a template. So if I run that file called app.r, that will open a Shiny app. And I haven't written any code, but the goal of today is not to show you how to write Shiny apps. There is a whole series dedicated to that. It's about how to actually host them on the cloud. So this example app that comes with the project itself is good enough. So I'm going to close it, and that's all I need. I already have an app. So I'm going to go to the terminal and move it to that mount directory. Remember, where from there I can then access it from the droplet. So now I'm here inside the container that is running on the droplet, not on the droplet itself. The container is fully insulated, and the only channel that I have to pass things to the droplet is through that folder that I'm mounted, is in the directory mount. So what I'm gonna do is I'm gonna cd into the home directory of this computer and call ls. Here you can see that there is a folder called app, the one that we just created. So I'm now gonna use sudo, because this is a privileged action, to move the app directory to the directory mnt mount, and that's about it. So that should move it. So if I do an ls now, I don't find it, but if I do an ls on mnt, then I do find it there. So that's all I need to do with this container. So I can close it now. That's all. So let's close this from here too. And now let me show you on the terminal. Now here we are on the droplet, not on the container. So we are at the host, or what used to be the host of that container. So if I do a docker ps, that container is there, but I don't need it anymore. So I could do a docker stop RStudio, which is the name of that container. Let's see. I mistyped that. RStudio, and that should stop it. And the next thing that I want to show. So now a docker ps again will not show it. It's gone because I set that remove flag. And now I want to show you that in the mnt directory, I have that app, right? So let's go to the notes, because I want to show you what's next. The next steps are very simple, really. Basically, the program that we're gonna use to serve the Shiny app is called Shiny Server. And Shiny Server expects the app in a very specific location. And if you put it there, you are effectively publishing it. So the address where you have to put it is actually described here. I'm gonna cover it in a moment, but for now, this is about it. So we need to have inside another directory called /srv for server, another directory nested in it called Shiny Apps, and there we can put our app. So we can move the app with these commands. If you are not familiar with the terminal, you can watch the series, the DSync series about it. So basically here we are making a directory inside the server folder called Shiny Apps. And then we are moving the app that we have already in mount app. We are moving it all the way to server Shiny Apps. So let's do that with the terminal. So I have this mnt app. So I'm gonna move mnt app to server Shiny Apps. I already have that directory Shiny Apps, so I'm going to show you the contents of srv Shiny Apps. Well, actually, the contents of srv to begin with, there is a couple of other folders that I had pre-created, and inside that, if you have a look at Shiny Apps, you can see that I have the app that I just moved and another app, which is one that I created before, so that this example is a little fast. So with this, I want to demonstrate that you are not limited to just one app. With Shiny Server, you can serve as many apps as you want. How does it work? Okay, let me show you that. So basically, we have already covered the publishing. So this step could be publishing the app, basically moving it to this specific directory inside the droplet. And now the last bit, which is the most interesting one, how to serve that app. So the apps are there, but they don't do anything if there is not a program running that can serve them. Basically, it's going to be running R in the background, and it's going to interpret that app as a website. So let me copy this code right now, and before I run it, kind of describe it a little bit. Similar to what we did before, we're going to do Docker. We're going to ask Docker to run a specific container that is coming from the image Rocker Shiny. We're going to remove that container when we stop it, so we don't have to do cleanup. It's going to be detached so that the terminal is interactive. Now the address where the droplet meets the container is a different one. It's 3838. That's what it is for this image. If you need to know more about the idiosyncrasies of this image, here is the link. We're going to name it Shiny. And we are also going to map a couple of folders. Like, remember the volume flag, the one that allows us basically to, whatever we put in this server Shiny apps folder, the two apps that I have, are now going to appear inside the container that is running running Shiny server, is going to appear in this other folder. Why this name is not the same than this one, I don't know. But it is what it is. That's what's described in this documentation here. And the same thing for the logs, although we are not going to be talking about the logs today. This call comes straight from this URL, so I wanted to reproduce it exactly. Okay, so let's run that. So I'm going to copy this. If anyone here is noticing that I'm close to the end, I noticed as well. So I think I'm going to push to the end because I don't have a lot more to say, and then we can open the floor for questions. So the Shiny server program is already running in a container. I can show you Docker PS. I have this Shiny container running. And where do I find it? Well, by now you may have some intuition about that. So we get that address. That is the address of our droplet. And then we need to add the address where it meets the Docker container. In this case, it's 3838. So here we have an index of all the apps that we have in that folder, Shiny apps. And we're going to click, I'm going to do control click here and control click here. So I have these two apps, just to demonstrate I can serve more than one. The one that we created, it was called app. So the URL is the one we typed plus the directory app, not surprisingly. And that's a live app. You can use it that way. Notice the title here. And now the second app, I did the same thing. The only thing that I changed is the title, just to demonstrate that it's a different one, but it looks the same because I used the same template already. I was a little lazy there. And also on a live app. So yes, that is how you create, publish, and serve Shiny apps using the cloud and Docker in particular. So for resources that contain details about what we covered, I recommend these four. The URL that points to the Rocker project, particularly where you can see what images they have, this explanation about how to use volumes, because we covered them today, and you may have not kind of fully grasped the concept. Also, the description about how to serve Shiny apps with Shiny. So this is the URL where you want to find details. And if you need a more gentle introduction to Docker, then I recommend the DS Incubator series about that. Okay, that's all I wanted to say. Let's go back to your faces and see if we have any comments or questions. Maybe I should mention a conversation we held in the background with Alex. Faria, I noticed your hand. Go ahead.
Yeah, I just, this might be a little bit naive, but are all Shiny apps hosted on the cloud? So when you make a Shiny app, it's automatically hosted on the cloud, or do you have to do some process before to make it available on the cloud?
Yeah, sure. I mean, you can create a Shiny app locally in a computer that is offline fully, and basically a Shiny app needs a computer running on the background. Let's call that a server. Basically, a server is a computer that serves a service, right? So if you have a computer yourself and you create a Shiny app, that thing won't work unless there is a computer serving that Shiny app. Because Shiny apps, what it's doing is actually running at the background running R and then doing computations and exposing the results of those computations on your web browser as HTML, right? So that's the whole thing about Shiny. So, but your computer is a server itself. So your computer knows how to do computations. So Shiny locally can kind of create a little server for the app itself. So you don't need internet, you don't need nothing, right? So basically what I did when I show how I created the app and then I clicked the button run. So in that moment, the Shiny was being served by the same computer that created it, which is the same thing that would happen in your own computer. Now, I did that creation and that serving of the app in a way that is not as natural. I did it already on the cloud, right? And then the publishing of that app was simply to move the directory that contains the app. So I created a folder called app that contained the Shiny app, basically, which was a file called app.r. That's all that I needed. And one file that just was the RStudio project. So that folder as it is a self-contained Shiny app. And the way I published it on the cloud was simply by moving it to a very specific directory inside the computer that was going to serve it, which was on the cloud. So for you, if you have a Shiny app locally in your computer and you want to put it on the cloud, you have to do kind of what I did here, basically. Somehow, I'm going to talk about that more in the next meetup. So if you have a folder in your local computer, how you move that to the cloud, right? Today, what I did is I created it already on the cloud, so I could kind of save a little bit of moving around. But yes, I mean, somehow you need to manage to move that app to the server that is going to serve it. Basically, that's how you publish it. If you need other people to access it. If it's only you, then you can serve the Shiny app in your own computer, or you can also stick it inside an R package and distribute the app inside an R package. That way, because every person that installs a package also has a computer, right? They can serve it themselves. So many Shiny apps are served that way. So basically each person serves their own app, but you as an author distribute the app not through a like a remote cloud computing service, but instead through an R package. So that's an option. Too long of an explanation. Sorry if I went through.
No, it's okay. Thanks for making that clear.
Yeah. I think it's going to make more sense next time when I show how, I mean, it's very simple, straightforward, but it just was too off topic. How to copy a file or a directory like a Shiny app from, say, your computer to the cloud or from the cloud to your computer. So the comment I want to not miss is that, when I started thinking in terms of, okay, how many apps you can, it's kind of great in a way that if you already have a cloud computer service, you can put as many apps as you want there and there's no limit, right? So that is cool because the alternatives are not free. So if you use, for example, the simplest way to serve a Shiny app online would be something like shinyapps.io, and the free account comes with something like five apps or something like that. You can pay a little money, it's not a lot, and then you have a lot more apps that you can serve, but still you have to pay some money. So if you already have cloud services for all the use cases that I showed, you better use it for serving Shiny apps as well. But then, like very wisely, Alex pointed out, okay, there is a point where you need more resources, because what if your users get very excited about the app and they use it a lot? And if I have a droplet with 1 gigabyte of memory, it's going to explode. It's not going to do it, right? Okay, so my immediate reaction, and also being very naive about Kubernetes, is, okay, maybe I can stick it in a Kubernetes framework so that Kubernetes will detect that it needs more resources and scale up, basically automatically giving more droplets to the user without them knowing, so that the app never kind of runs out of resources. But then he mentioned that the danger of that is that you need to you could be in a position where your user gets super excited, Kubernetes creates 1 million droplets, and your bill because you pay by droplet, your bill goes up crazy. And it has happened. He says that like someone developed this very popular product, and in 1 week the bill went up to something like $50,000 or so, which I don't have, right? So to pay for an experiment. So yeah, be mindful that. So long story short, there is a point where maybe serving Shiny apps on a small droplet won't cut it. And if you're thinking how I thought, okay, maybe I can serve on Kubernetes, Be careful because your bill could go to the sky. So you have to be sure that you know how to control or cap, if you want, how much you're going to spend. And that was another long explanation. Monica, go ahead.
Yeah, I just had a quick question. Do I understand correctly that what you showed us now is more like a customized way to serve a Shiny app, but there is also a more default server, this shinyapps.io, you said?
Absolutely, yes.
That would be like the go, or like the simplest.
Absolutely, yes. So if all you want is to share an app that is public with the world, my go-to would be shinyapps.io. That's the simplest, and you can connect. How I have it is like when I run an app, there is a button in our studio that says publish, and I connect my account on shinyapps.io to that. So I just click publish, and it goes there. So that's the simplest way. What I showed today is that so the issue with shinyapps.io is that you have a limit about how many apps. I think it's here somewhere here. So if you want to pay nothing, you have 5 applications that you can serve, only 5 Shiny apps. For $9 a month, you get 25, and unlimited for $40 a month. I'm probably spending less than $40 a month for a bunch of services that I use on the cloud. So because I already have a cloud service, then I better use it to serve Shiny apps. So that was the goal of today. So yeah, certainly it's not the simplest way. But also notice that what I did is, so this thing is not private, it's public, so it's a good thing to mention. So this, if you go to this address now, it will work for you. Like I'm gonna now open a private browser here that should not know. Let's see if I can do it. I know what, my session froze. But this thing is public, so if you type this URL, if I give it to you now, you access this app. So it's published on the world, really. So for the user of your app, nothing of what I showed is relevant. The user just goes to a URL and they can use your app. So that's the exciting thing, that someone like me could be doing all the heavy lifting and building all the infrastructure, but then Shiny just gives access to R to people that don't know R. Just by giving them this URL, they can use your app, right? And it's only because I want to get into the trouble of serving it myself on DigitalOcean is that I did so, but you don't have to.
Okay, cool, thanks.
You're welcome. All right, Alex did my rephrasing of what you said, more or less. What was it, a good one? Or I want to give you the opportunity to say, hey, I didn't say that.
Yeah, no, that was spot on.
Cool. All right, thanks everyone. That's the end. We went a little over, so thank you. See you next time.